Hello guys, welcome back to another video. So now we are in second assignment on linear regression. In this assignment again, we will use the German credit dataset that we used earlier in the first assignment. So without further ado, let's see what the first question is. So first we have synopsis given here. It says for the German credit dataset, perform regression on amount using the other numeric variables as the independent variables in R. Use LM function. So this time we will have to do multiple linear regression. Earlier in the first assignment, we did simple linear regression. So as usual, first we will have to read the CSV file. So we will use read.csv function and read a CSV file as shown here. We will then store it in a variable called German_credit. After that, we will take a random sample of 500 observations using the sample function and store it in a variable sample_ger. After taking the sample, we will filter our sample and only keep the numeric values. So we will use sapply function. And the first argument would be sample_ger, which we have created earlier. And the second argument would be the function, which is is.numeric. So it will return true for all the numeric values and false for all the non-numeric values. Now using these values, we will subset our sample_ger using the square bracket. And then we will store it in a variable called German_num. So this will only contain the columns that are numeric. Now before creating the regression model, we will first create the training and test split. So let's say we will have 80% observation as training and 20% as test. You can even do a 70-30 split or 75-25 split or any other number. It is up to you. So to create this split, we will again have to use the sample function. So the first argument would be 1:500, which will be used by the sample function to generate the sample from. And the second argument would be the sample size, that is 500 into 0.8, which is basically 80% of the total data. This we will store in a variable called trg. And then we will use this trg variable to subset the rows from our original data frame, that is German_num, which contain only the numeric columns. We will store this in a variable called trg_German_num. Basically, it means training observation of the German_num data frame. So how did we create it? Let's suppose that the values in the trg variable are like 1, 4, 5, 6, 8 and so on. So these numbers are used to subset the rows of our data frame German_num. This is how we have created a random training dataset. Similarly, we will create a test dataset, but this time we will use a minus sign before the trg variable, which means all the numbers other than the numbers given in the trg variable. So if trg has values 1, 4, 5, 6, 8 and so on, it will subset rows other than these rows. This is how we have created a training and test dataset. Now we will use the training data to train our model and test data to make the prediction. So we will create the regression model using the LM function as shown here. Now as the question is asking us to regress amount onto all the other variables, so we will just use a tilde symbol after our dependent variable, that is amount, and we will run this and store our model in a variable called regression_amount. Now this tilde symbol is on your keyboard on the top left hand side, just next to the number 1 key. This tilde symbol means that we are considering all the variables in the dataset. So this is how our model is created. Now we will use our model on the test data to make the prediction. For making the predictions, we have predict function in R. So predict takes minimum 2 arguments. First argument is the model and the second argument is the data upon which prediction is to be made. So here the first argument is our model, which is stored in reg underscore amount. And the second argument is the test data, because we have to make the prediction on the test data and not on the training data. We will run this code and store it in a variable called predict underscore amt, which means predicted amount. Now we can use the head function to see the first 10 values of our prediction. We will also check the R-square, etc. to see the accuracy of the model, but we will do it later. This was just to give you an idea about creating the model and then making predictions from it. Now moving to the next part, it is asking us to answer questions from A to G. So the first question, question A says, generate the LR equation. Now to generate the equation, we would need coefficients from the model that we have created here and the intercept term. So let's see how do we generate the equation. For doing so, we will use a for loop to generate regression equation using LM results, which means the results from our model. So if you subset reg underscore amount, which is our linear regression model, using coefficient command, you will get values of intercept and other coefficient with their label. So our task is to take each coefficient and multiply it by the name of the variable to convert it into an equation form. So the easier way to do it is to print the coefficient and then manually multiply it by each name and then print the equation. But the wiser way to do it is to use a for loop and then extract the coefficients. So let's see how are we going to extract the coefficients. First we will define a null vector E. Then we will create 6 plus signs and store them in a variable R. And then we will also need names of the variable for our equation. So we store the names of the variable in a variable called name. So we are just subsetting a data frame German underscore num, but excluding the dependent variable by putting a -3 within the square brackets. Because amount is the third column in our data frame and this will exclude the third column. After this, we will initiate our for loop. Our for loop will run from 1 to 7 because we have 7 variables. So we will use paste function here. We will join the output of the coefficients with a symbol x, which is the multiplication symbol, with the names of the variable, which we will subset using the name variable that we have created earlier. And we have stored the plus sign in a variable that we have created earlier, which is R. All this will be stored in a null vector that we had created by the name E. So that is how we will extract the coefficient from the for loop and print it in the form of equation. Now the output of the loop, which is stored in the variable E, is not a string. So we will convert the output of the loop into a string. But why we are doing this? Because we check the structure of the variable E, it stores 7 characters and each character is within the quotes. So for printing the equation, we will have to convert it into one string. That is the reason we are converting it into string. Now to convert it into string, we will use the function toString. The first argument would be the output E, and then we'll mention levels is equal to drop. This will convert it into string or a one-line text. We will store this in a variable called A. Now the other part of the equation is the intercept term. So we will add the intercept term to the rest of the equation. So we will again use the coefficient function. We will subset the first element of the coefficient function, which is basically the intercept term. Then we will use the paste function and put a plus sign and the rest of the equation, which is stored in A. Now this entire equation will be stored in a variable called B. Now if you print this variable B, you will find that the entire equation contains quotes. So finally we will remove the quotes using the gsub function. So the first argument of the gsub function is basically the character that needs to be replaced. The second argument of G sub function tells it with what this character needs to be replaced. And the third argument is the variable from which this character needs to be replaced. So this way G sub function will remove the quotes from this equation. Now as you can see, I have used the paste function as well. I have used paste function to paste the left hand side of the equation, which is amount, and in the end we have written collapse is equal to quotes, which will convert the entire equation into one string. Now we can run this entire code to print our equation. After running this code, we have our equation printed as shown here on the screen. Now if you see below, I have included the explanation of this code. So if you find it confusing, just read through it, or you can rewatch this part of the video again. Now as I said earlier, I could have just written this equation manually by noting down the coefficients and then multiplying it by the names of the variable. But my approach is to teach you guys something new every time without explicitly learning a function of R. So if you see, here we have learned some new functions and also expanded our knowledge of loop. So that was the whole reason to include this example here. Now we will move to the next question. The next question is asking us to use the summary function for the model to view the diagnostics and write a summary of the results. So we will use summary function for our model, which is stored in reg_amount, and will print the results. Now from these results we can conclude the following. The maximum slope is for the variable default, and therefore with every single unit change in the variable default, the amount will be changed by 195.430. The variable installment has a negative slope, and with every unit change in the variable installment, the amount will change by minus 836. Then from the f-test results, we can see that the p-value is less than 0.05, which is our significance level, and hence we have strong evidence to not reject the null hypothesis, which says all these 7 variables collectively do not have an impact on the response, which is our amount. It also shows that R square is 0.4784, which means 47% of the variability in the response is explained by the model. So this is the information we can extract from our model using this summary function. Now we will move to the next question, which is question C and question D. Now question C is asking, do you like the model? If yes, then why? And question D is asking, if you do not like the model, then why not? So basically you have to give the justification for your stand, whether you like the model or not. So I have given answers to both these questions. You can pause the video and you can read through it. But I am skipping it and I am moving forward. But this is a good question which will make you think about the data and your results. So you must read through it. Now moving to the next question, which is question E. It is saying, how will you determine what is the best model? Now again the entire answer is printed here. You can pause the video and you can read through the answer. But remember guys, this is not the only answer to determine which is the best model. There could be other factors as well which will help us determine the best model. But in general, this is one of the ways which will help us to select the best model. Now we'll move to the next question, which is question F. Question F says, how do you add interactions? So remember we have learned interaction terms. Now in this question we will learn how to add those interaction terms. Now we will only add those interactions or only those variables which are significant. We will not add insignificant interactions here. We can find out the significance of the variable using the p-values. So if you go back to the results, you will find that there are two variables, duration and age, which are significant. So we are considering variables with 2 star and 3 star as significant. Now we will use these variables to add our interaction term. Now as you can see on the screen, everything in the LM formula remains the same, except that we will add an interaction term after the tilde. So we have a response variable amount, then a tilde, then a full stop, and then plus. Then the second argument is the data, and that's it. We will run this and we will store it in a variable called reg underscore amt underscore int, which basically means regression of amount variable with the interaction term. After that, we can use the summary function and we can view the summary of our model. So we can see in the output our interaction term has been added in the table. We can also see that r square has also increased a little bit. Now right now we will not go into more details. This was just to show you how you can add an interaction term in the model. So that will be all from this assignment for now. Let's quickly revise what we have covered so far. We have learned to create regression model with multiple variables. We also made the prediction using the predict function. Then we learned something new by writing the regression equation using a for loop from the model results. Then we learned to interpret the summary of the regression model. We also brainstormed a small summary explaining the merit or demerits of the model. Then we discussed the criteria for accepting the model as good or bad. And finally, we learned to add the interaction term in the model. So that is how we are moving into more advanced concepts gradually and learning new concepts in every assignment. I hope you are finding these videos helpful. Stay tuned for more important concepts in the next video. Until next time, see you.